Welcome to the Unified Principle demonstration by Aries Grant. Using 56 discrete nodes derived from the 364-day year, orthogonal anchoring at 30, 60, and 90 degrees, and the lambda g constant of 9.7705, the Unified Principle provides a coherent structural framework for all 7 Millennium Prize problems. Aria Nova will now guide you through each resolution. Chapter 2 of 7. P versus NP. The apparent gap between solution discovery and verification is a computational contradiction within the Unified Principle framework. The UP mandates convergence of verification and discovery paths. P equals NP is an axiomatic necessity. The omega naught mandated state eliminates all logical inefficiencies between discovery and verification. Fibonacci 56 collapses all search geodesics to a single verified path at the ring center. Verification is structurally polynomial inside the 56-node system. Chapter 3 of 7. Yang-Mills. The mass gap is required to maintain field coherence and prevent infinite range contradictions. The omega naught state necessitates a positive mass gap, ensuring localized, stable quantum fields. Lambda g at 9.7705 discretizes the four-dimensional vacuum into 56 nodal walls, enforcing confinement through structural necessity. Each radial spike at 30, 60, and 90 degrees represents the minimum field energy separating the vacuum from excitation, the mass gap made visible. Chapter 4 of 7. Riemann. Prime distributions must maintain maximal order within the Unified Principle framework. Any zero of the Riemann zeta function off the critical line, Re of S equals 1/2, violates the omega naught mandated minimal complexity. When drift exceeds lambda g, the 56-node ring snaps Re of S to exactly 1/2. The solar azimuth forces alignment. All non-trivial zeros are structurally bound to the critical line by the same orthogonal anchoring that governs the ring calendar. Chapter 5 of 7. Hodge. Algebraic cycles are the omega naught representation of topological structure within the UP. Non-algebraic cycles introduce topological contradiction and are structurally forbidden. The UP's orthogonal anchoring at 30, 60, and 90 degrees mandates that all Hodge cycles on a projective variety are algebraically representable. The four orbital rings and their 90-degree diamond anchors demonstrate that every cohomology class achieves algebraic closure through the ring's invariant preserving cyclic correction. Chapter 6 of 7. Birch, Swinnerton, Dyer. The rank of an elliptic curve reflects the minimal recursive complexity required for its coherent existence. Elliptic curve structures and L-function behavior are inseparably linked through the unit sphere and the 56-point node system. The 13 lunar cycles of the 364-day year bind the L-function order to the curve's rank through phase lock coherence. Where the elliptic wave and lunar ring lock, the orange diamond, the rank of the elliptic curve equals the order of L of E at S equals 1, made structurally necessary by the UP. Chapter 7 of 7. Poincaré. The three-sphere represents the minimal complexity, omega naught, state in topology. Ricci flow, interpreted as coherence flow within the UP, inevitably reduces any simply connected compact three-manifold to this spherical canonical form, fulfilling the requirement of maximal coherence. The solstice anchor at day 0, where omega equals 1, is the topological ground state, the perfect S-cubed sphere to which all manifolds must return. This conjecture was proven in 2003 by Grigori Perelman, confirming the UP structural prediction. Chapter 1 of 7. Navier-Stokes. The global smooth solution is the axiomatic necessity, omega naught, for fluid systems. Turbulence represents maximal dynamical contradiction, which is forbidden by the UP framework. The UP mandates that any valid initial condition must produce smooth solutions, ensuring omega naught at all points.